this is Java Lesson 6, and today we're going to be talking about abstract classes and interfaces. This is an extension of what we learned last class, so if you haven't watched the video yet, I highly recommend watching the last video. So for abstract classes and interfaces, whatever class implements it, it must also implement the methods inside of it. We'll see what this looks like later. You may add methods, variables if you like, but you must implement what's inside the abstract class / interface. These are called abstract methods, and we'll take a look at these when we implement it. So first, let's try to implement an abstract class. An abstract class looks a lot like a normal classes, but uses the keyword abstract in front of class. So let's say that we want to create an abstract class animal. We would create an animal class like this, but in front of class we would put abstract. This tells Java that animal is an abstract class. Now you will notice that a lot of the things we put in here look very similar to the normal class. For example, we have a private variable name, and we also can put in a constructor, public animal, and then we want to take in the argument of string name. Now what we do with this argument name is we will set this name right here to this name. So we do this.name, and this.name always refers to the one that's outside. So the private variable is equal to name. And we can do methods such as public string get name, and we'll have this just take no arguments, and we'll return the name, as our method has the return type of name. Now an abstract method will look like this. Just like our normal method, we would do public string to string. However, instead of a body, abstract methods do not take any body at all. It doesn't show the implementation. And right here, we would put abstract. So it's public abstract, then our return type, and then the name, and if we want, we can put in what it takes. So for example, I could do something like int num, but I'm not going to. Now I'm just going to compile this, and we see that it compiled. Compiles command B. Now I'm going to create a dog class to go with this animal. The dog class is going to look like just any normal class, except if we want to make the dog class implement animal, we have to use the extends keyword. Now, just like in our normal classes, we will make a constructor, public dog, and we'll take in the string name. Now, because our class dog extends animal, and we already have the constructor for animal here, we can do something called, we can create a super method. Now super will just call the constructor of the class that extends animal and use the animal's constructor. So we'll call super name, and it will look into the animal class and see, okay, what constructor in animal class takes in one argument, which is a string. And it says, okay, this constructor, and then it will set the dog's private variable name to name. Now, we also have to implement all abstract methods inside animal. So we have to implement this public abstract to string method. We would do this by saying public string to string, and it must be exactly the way as this, as the same return type, and it has the same parameters, but in this case we don't have any. Now in the body, this is where we actually implement it. Our animal class doesn't have the implementation, so we have to implement it ourselves. I will call return get name plus says woof. Now I can compile this. Alright, I can't have it be public because we already have the public class lesson 6. So instead it should just be a class. Now I can compile that, and now I can create an object of dog. So dog D is equal to new dog, and let's just call him Jared. And I will just say, I'll print dog. And remember, whenever I print D, it will see if in the class I have a toString method. Now, when I run this, it says Jared says woof, just like what we wanted. Now, let's see how this differs from an interface. An interface is a lot like an abstract class. However, interfaces can only have abstract methods. So this method right here in our abstract class, getName, we cannot have it. So none of the methods in an interface would be implemented. I would just make this like this, and I'll say animal interface, and inside it would just be string getName. Remember, this is abstract methods, so it only has this return type, the name of the method, and the parameters that it takes. And we'll also create another public string toString method. I can compile this, and now in our dog class, instead I can now make it so that the dog implements the animal. So I can do here, I'll use the keyword implements, and then I'll use animal interface. Now I have to create the private variable name, so private string name, and instead of calling super, because there's no constructor in the interface, I have to create my own method. So I'll just do this.name is equal to name. Now I also have to create this getName method, as it is an abstract method that we have to implement. So public string getName, and I'll implement the body, and I'll just say return name. I can compile this, and now I can run it. Just like in the previous example, we have Jared says woof. I created this dog, which now implements the interface. I call the constructor that we created and set this name to the name here. Now in our toString, I'm calling getName, and getName is an abstract method in the animal interface. So is toString, so I must implement those, and there's no exception. If I don't implement it, for example, let's say that I comment this out and run. Oh, okay. Maybe toString isn't the best because toString is already implemented in Java by default. But let's say I comment out the getName and run this. You'll see that I have dog is abstract and does not override the abstract method getName. You can see that Java does not allow you to not implement the method. You must have an implementation somewhere in your class. Okay, before we end this video, let's quickly review what we learned today. So first, let's compare abstract classes versus interfaces. For abstract classes, you can implement abstract methods, normal methods, and even private variables. However, the normal class can only extend one abstract class, and it also uses the keyword abstract to create the abstract class. Whereas in an interface, we can only have abstract methods. However, the interface uses the keyword interface to create, and classes can implement multiple interfaces. If we implement multiple interfaces, we also have to implement all the methods in all of these interfaces. Now, abstract methods we can create using their declared and specified return type, method name, and arguments. However, they do not have the implementation, or the body of the method. You create it using public abstract return type, the name, and then if we need, we can put arguments in. This is how we would create an abstract class. As you can see, we have things such as variables, constructors, and methods, as well as abstract methods. The dog class will extend the animal class, and in the constructor, we will use super to call the class that extends constructor. So in this case, it would call this constructor right here. And because this method toString is abstract, we must implement it. For an interface, all methods must be abstract, so you don't necessarily need the abstract keyword. We also have our class dog will implement the animal class, and we must implement these abstract methods getName and toString. Thanks for watching this video on TheCodeBakery.